This is some of the easiest math you'll do in this chapter. So the problem gives you a mole amount and a kilojoule amount, and it wants you to solve for delta H. What we know is that delta H is equal to Q, that's our heat energy, divided by N, which is our moles. So energy and moles. And traditionally it's in kilojoules. Doesn't have to be, just watch your problem units as to whether it's in kilojoules or if it's in joules. Most of the time it's kilojoules though. The other thing to know is to pay attention to problem wording. Notice it says that it produces this much heat. It's saying that heat is a product in this reaction. So when heat's a product, remember your delta H value in this case will be negative. If it had said heat was absorbed, then heat would have gone on this side and your delta H would have been positive. All right, so all we have to do is take our number, 8.55 kilojoules, and then divide it by our moles, 0.0547 moles. And then that should give us the number that we want for the problem. So we'll go ahead and just bring this over here, and we'll say negative 8.55 divided by 0.0547, and that gives us delta H is equal to negative 156 kilojoules per, and this is an understood 1 mole. Now we'll do the next problem. In this case, we have a gram amount, and it's producing this many kilojoules of heat. Remember, delta H is equal to Q over N. And in this case, delta H is equal to, it says it reacts with extra water. It produces, so again, that means it's going to be on the right-hand side. Delta H is negative. And so what we're going to do is we'll just take our 500.0 grams of CaO, and we're going to turn that into moles. So if we know that it's 56.00 grams in 1 mole of CaO, so CaO, then that's going to give us our mole amount. So I'm going to bring over the calculator, and I'm going to put 500 divided by 56.00. And so that gives me my mole amount is the 8.9286. We'll just put some extra sig figs in that one. And then that's the N value right there. That's the N value. And then my Q is what it tells me. It's this 581.3 kilojoules. So that per mole, 9286, is going to be negative 581.3 divided by 8.9286. So that gives us that it's negative 65.1. Looks like I've got 4 sig figs in here, so 1, 2. And that gives us kilojoules per mole.